Hi, hello everyone. Welcome to ML Summit and Vanguard's presentation around how we are modernizing financial services through automation. This session will help you learn how automation is used for setting up ML environments, and it will help you with your clients and improve their experience. With that as a background, let's start with agenda. First, I would like to walk you back through time. Then we can identify some point of pains and gaps we have identified, capabilities that were expressed as a need in the platform. And then we start diving deeper into how did Vanguard start this journey of transformation. And then we dive deeper into automation of model development, automation of model governance, and model ops. What progress have we made till date, and some key takeaways. As we start our journey and walk back through time, this will help you understand how we went through the whole process of building a platform with automation in mind. Our journey at Vanguard started with a proof of concept in fourth quarter 2018 using Amazon SageMaker as one of the platforms for machine learning. Post proof of concept, we moved forward into pilot implementation of SageMaker, and we rolled out SageMaker to multiple teams. Then in 1Q 2020, Vanguard progressed their journey towards utilizing SageMaker Studio, which was recently released in 2019 at reInvent, and we started performing proof of concepts with multiple teams. At that point, we realized that we are taking this approach of maturing over time, and maybe we have to take a step back. And in 2020 second quarter, we decided to bring all practitioners into a room and spent a lot of time over weeks and months to discover what their end-to-end capability needs are and what are their typical point of pains. This exercise with practitioners led to understanding how Vanguard can be better at machine learning and continuously evolve their maturity over multiple years. So let's start with some point of pains and gaps we identified. And I'm thinking that these point of pains and gaps will resonate with all of you and will help you identify similar point of pains. One, we have many tools at Vanguard, and many of those tools have partial capabilities. That creates a lot of friction in building a model, developing a model, and publishing a model. Many of these tools are very user-friendly to use, but it takes a lot of time to set up these tools. And once the tool and infrastructure is set up, many of the practitioners spend significant time on getting access to data, going through governance processes internally, etc. In addition to going through governance, complexity of data is also an area where we find a lot of point of pains. Another area that I would recommend everybody to investigate would be around inconsistent use of terminologies. Vanguard has that gap where every team at Vanguard uses different terms and terminologies, etc., as they build, develop, and deploy models. Those are some of the gaps, but there are many more that you can identify within your own organizations and build a strategy around how to resolve these point of pains. As we identify point of pains, we also asked our practitioners, data scientists on what capabilities you need. And we categorized all these capabilities into three major areas. One we call model development or model dev. And in there, data scientists and practitioners express they want to automate the setup of their environment. They want to be able to prepare data very easily. They want to use notebook-based environment where they can build, train, and experiment with model and also track those experiments. In addition to having notebook-based environment, they also would like IDE-like features like debugging, variable exploration, see the values, etc., so that they can effectively write either code in the notebook or outside the notebook. They also expressed integration with code repositories and many other capabilities from a perspective of debugging the model, profiling the model, and also in explainable AI concepts such as bias detection, etc. Apart from model development, they also expressed interest in capabilities that we categorize under model governance, where we felt that we would want to establish a wide enterprise-wide governance policy that would help us identify appropriate level of risk and controls that have to be adhered to minimize risk. We also identified that each team follows a different life cycle when it comes to model development or machine learning, and standardizing it would be a good thing for Vanguard and for the whole community. Apart from that, many practitioners identified gaps in lineage and tracking capabilities of their models so that they can make sure the model that they build and they deploy can be tracked back with what data it was built with, who built it, when did they build it, etc. And any updates made to the model would also be should be trackable. And then they wanted model explainability capability, where they could explain their model, they could validate their model before putting out for deployment. The third category where we saw a lot of capabilities needed were in the model ops area. Vanguard has many CI/CD pipelines, but most of them are not tuned for model development and model deployment. So the request was to come up with a pipeline that is very tailored for this kind of workload. Also, they wanted this pipeline to support different types of deployment, either use AWS native algorithms or allow data scientists to bring their own custom algorithms through custom containers, and also allow this pipeline to deploy models as APIs or could deploy the same model as batch inference. Apart from providing this pipeline, they wanted different ways to deploy model so that they can perform A/B testing. So there has been ask for canary deployments so that they can use variants and other capabilities, blue-green deployments, and also be able to chain models into an inference pipeline so that they can use multiple models to achieve their outcome. From a monitoring perspective, there are different monitoring capabilities that were requested to measure data quality once the model is deployed for consumption, look at model quality, data drift, bias drift, and many other capabilities in that space. All these capabilities together, we felt would help us build a platform for few years out. And we started with the thought of, if we always go and build the platform the way we have built the platform, we'll always get what we always got. And we need to take a different approach this time, rather than taking the same approach of building platforms based on point of pains and capabilities articulated. That's where our transformation journey started, and we based our path of enabling a new platform based on the OKR framework of objective and key results. As part of that exercise, we first set ourselves some objectives as a platform team that uses automation to enable platforms. Our first objective was around reduce lead time to set up a usable platform by the data scientist. Second, reduce lead time to enable consumption of the models and machine learning models built on this platform by the consuming applications, microservices, and others. As we reduce lead time on these two things, we also set ourselves objective of reduce risk due to usage of machine learning, as that's a huge component of machine learning where we want to build explainable and ethical models that help our clients. Finally, we also set ourselves an objective of we want to reduce manual touch points between the data scientist and the platform teams or IT teams that help these data scientists to build what they build on a daily basis. Now let's look at some key results that are tied back to those objectives. We set ourselves a key result of less than 24 hours to set up a usable platform, automate 100% of deployments of model and no manual intervention, automate 90% of controls that we want to validate, and less than 10% of manual support touchpoints. These key results are multi-year long key results, and hence we call this transformation as a journey and not just an outcome of a year worth of effort or a 2-year worth of effort. Before we even started acting on these objectives and key results, we set ourselves some principles. First one was favor automation over anything that has to be done manually. Focus on achieving an outcome over just output of delivering a capability, and focus on the outcome that needs to be achieved. Make incremental progress over perfection so that we can start deploying capabilities to the data scientists so that they can make value out of what they are working on. And finally, allow data scientists and practitioners to focus on their core job of building models using machine learning rather than spending time on contextual things of setting up the platform, getting access to data, etc. Hopefully these principles and objectives and key results resonate with you all, and you can apply this concept of transformation using OKR and principles. Now, how did we start our journey of transformation? Before we instrumented any capability in the platform, we first went ahead with defining a policy for model development at Vanguard and tied that policy with a model development lifecycle. Model development lifecycle was defined with multiple phases. First phase was where a business unit would come to data scientist and define a problem, and the data science team that is building the model would capture the problem and figure out in details what exact problem needs to be solved. Post that, they would go look at the problem, prepare data, get access to data, and transform the data for their needs, and start building a model and training a model. In real world, phases 1, 2, and 3 that I have articulated are always iterative process at Vanguard. They are not once and done kind of. So there's always back and forth between defining a problem, prepare data, and develop a model. And this whole cycle or whole part of that cycle, we deem internally as a model development activity. And once a model is developed and validated for consumption, data scientists and engineering teams would adhere to controls and make sure all those controls are followed and validated, post which they would enter a phase of deploying the model for consumption. And as part of deployment of the model, they would also set up monitoring capabilities for the model to ensure model functions as expected. And if model starts drifting or doesn't function as expected at times, we go back into the life cycle to either look at the problem again and go through the whole life cycle with preparing data, retraining the model, deploying the model, and monitoring again. The whole process of deploying and monitoring is deemed as model operations at Vanguard. And we adhere to a principle of having governance be performed at all these phases and not at just an isolated beginning of the life cycle or at the end of the life cycle, but governance concepts are applied at every phase of the life cycle. Now that you understood the life cycle that we have built out, we went and talked with practitioners on, let's now focus on achieving an outcome of building you an environment for model development. And we had interviews, and based on those interviews, we categorized their needs into 3 areas. One is tools and data setup. Second would be around knowledge base, so that when they run into issues, they can easily identify how to solve the problem. And third was around problem management, where if they run into problems, how to reach out to various support teams fast to resolve their issues. Many of these capabilities today are available, but they are extremely manual in process and take up significant time to resolve issues. So we explored as Vanguard many different options. From an automation perspective, we looked at tools like ServiceNow. We tried to build it ourselves as a web application. Eventually, we felt that best experience we could provide to our data scientists was to build a chatbot. And we enabled a chatbot starting with tools and data setup. This chatbot uses native AWS capabilities such as Amazon Lex. The UI runs on Fargate containers, and single sign-on is established using Okta, Amazon Cognito, and we use ELBs and other technologies to fulfill requests that these data scientists have. Iteration 1, as we said, we want to focus on progress over perfection. We focused on delivering the first capability of tool setup and data setup through the chatbot, and we are working towards enabling knowledge base and problem management capabilities through chatbot. This was our first foray into setting up using automation to help our clients. As part of this automation, we'll take more deeper dive on what all does this chatbot do from a setting up a tool and data perspective. As part of this automation, data scientists come to the chatbot first to set up what we call a team within Vanguard, and chatbot goes and creates a IAM role and provides access to various SageMaker capabilities such as SageMaker Studio notebooks, SageMaker distributed training, SageMaker debugging and clarify, SageMaker model registry, and Athena. This all is set up through the chatbot as the first step. Next step is data scientist interacts with the chatbot and works with the chatbot to set up access to data. As part of that setup, chatbot takes the IAM role and updates it with what S3 buckets does the data scientist want access to, what experiment buckets that they can rewrite into, sets up access to Postgres RDS. And in future, we are looking at setting up access to Glue Data Catalog and DynamoDB and all other various sources. Once you have set up the tool, you have set up the data, next step you work with the chatbot is you use SageMaker Studio's projects capability and associate and create a project with the data that you need. As part of this setup, chatbot also behind the scenes creates the CI/CD pipeline and sets up code commit repository and various other capabilities that are needed for CI/CD pipeline. Finally, data scientist comes to the chatbot and associates that project to the team. And at that point, data scientists can start working with the tool, with the data, and start building their models and training the model. The whole setup process before this automation would take anywhere from 3 to 4 weeks at Vanguard. Once the chatbot was set up, after asking these questions and answering and interacting with the chatbot, the whole setup takes less than 2 hours at Vanguard. And we want to now improve it to make it even further better by reducing that time to maybe from 2 hours to an hour. Next, let's dive deeper into automation for model governance. Data scientists and teams come to this chatbot and interact with this chatbot as part of their project creation. And as part of that creation, they answer questions such as who's the owner of this model, who is the owner of this project, and they set up metadata on the SageMaker Studio project and also set up all this information all the way into model registry so that we can have end-to-end lineage of who built the model, who trained the model, who approved the model, who deployed the model, etc. Apart from that, we ask the data scientist a bunch of questions to understand the risk profile of that model and its consumers. And all that information that they provide to the chatbot is stored in a data store. Today we are using S3, and in future we may use some other store. Once we have this model governance set up, in future we are also working on enhancing this model governance for other capabilities like validating controls, etc. Next, I want to step into the phase of what do we do from an automation perspective for model ops. As part of model ops automation, as I indicated, the chatbot sets up CI/CD pipeline moment they create the project. And then we have put in a custom CI/CD pipeline using SageMaker Pipelines capability, where this pipeline performs security checks on the code and the model that was developed. It looks for code quality issues, if there are any, using different tools. In future, as I mentioned, we are going to validate controls as part of this pipeline. And then the model is picked up from the model registry, deployed to a pre-prod environment. Post-validation in pre-prod environment, we open a change record or change instance in ServiceNow, deploy the model for production, and then set up model monitoring for data scientists to continuously monitor the different aspects of it. Now let's focus on what progress have we made till date as part of this journey. as you can see, we have made significant progress in building an environment that is very conducive for model development, where we have automated the setup. We have provided a notebook-based interface for interacting with S3 and RDS and different data structures. We have notebook-based environment to build, train, experiment for native algorithms. And we are in process of finishing the work on bring your own custom models from a model development perspective. We have integration with code repositories and integration with model registry and model training workflows are also available to our data scientists. From a model governance perspective, we have established, or we are establishing policy. We have a life cycle that is defined. We have defined controls based on different risk tiers, and we tag models based on different tagging criteria to ensure we are governing our models appropriately. From a model ops perspective, we have a CI/CD pipeline that we have enabled for native algorithms and frameworks. Custom algorithms and frameworks is almost complete. And CI/CD pipeline for batch deployments is available for our data scientists to use. We have enabled canary/variant-based deployments, and we are working towards blue-green deployments as we speak. Apart from all these CI/CD capabilities, we have model monitoring capabilities enabled, including capture of data that comes as input and output. And all of this information is available to data scientists to monitor using SageMaker Studio visually on their interface. And we'll finally be working this year on notifying if there are any threshold breaches from a model monitoring perspective. At this point, I want to get into what are the key takeaways for many of you. I would say first one is around setup governance to foster ethical and explainable machine learning. Second one would be establish a life cycle and enable capabilities in support of that life cycle. And finally, enable data scientists to focus on core capabilities that they offer and automate everything that is meant as a context to them. With that, thank you for attending my session. You can reach me either through LinkedIn or via email as indicated. And please don't forget to complete the survey for this session. Thank you all.